So today we're talking about solving simultaneous linear inequations. So just as it sounds like, we'll have several linear inequations happening like on our graph, and we need to find the region on that graph that satisfies both inequalities. So when we were talking about just ordinary simultaneous equations, we're just finding the point where they intersect. Now, instead of just the point where they intersect, we're finding regions, so an area on the graph that satisfies both those equations. So let's have a look at one here that I've written up. So y is greater than negative 2x plus 6. And y is less than or equal to x plus 2. Now, let me draw my axes very, very badly. Do my little arrows at the end. And y and x. I have noticed that some of you don't put the y and the x or the little arrows at the end of the axes. You absolutely have to. Okay, no questions about that. Now let's try putting a scale in. This is where you're with a ruler. 1, 2, 3, 4, 5, 6. Better off than I am. Okay. So you can see I'm here making a scale that I'm trying to roughly make it equal on the x and the y. Okay, so equation 1, I might do that in red. Equation 1. Okay, it has a y-intercept of 6, 6, and its x-intercept will be at 3. Okay, now it is greater than, so that means it's a dashed line, isn't it? Because it's not including the value of that line. Now, I've got to figure out, do I shade above the line or below the line? Now, it's got to be greater than that, so, thinking if I was to substitute 0, 0 into there, if y equals 0, x equals 0, y, that means 0 is greater than 6, and obviously that's wrong, so that means we are going to be going above the line. So let me just get the red up again. So I'll be shading it like so. I also noticed that some of you weren't shading. You have to do some form of shading, even if it's just sort of these lines to indicate that shade. Also make sure that you are putting in the dashed lines if it's greater than or less than, because when it is less than or equal to or greater than or equal to, that's when you have the solid line. So before I do that, I better put in coordinates of my intercepts. So that's 0, 6, that's 3, 0. Okay, so we've got equation 2. Y is less than or equal to x plus 2. So my y-intercept's at 2. My x-intercept is at negative 2. And then that's a solid line because we include the line. That's a possible answer. Okay, so y is less than or equal to x plus 2. So again, I'm going to use 0, 0. It's a really nice, easy one to sub in. So 0 is less than or equal to 2. Yep, that is correct. So I'm erasing those so I'm not covering up the screen in a lot of things. So let's do my shading, this way. Okay, so you can see here, there's this region here, where the two regions overlap. Okay, so that is the region that we are most interested in. I might actually put another color over the top to make it clearer. So is it making it clearer? I don't know. But this is the region that satisfies both these inequalities. So you might see some graphs with just that area coloured. Okay, and so you could then go through with your pencil and erase these and these, or you leave your shading till afterwards. Now you can also, of course, do these on the CAS calculator. Let's bring that up. So Control I to bring up new page, and let's have a graph. Now, quick way to get there is I just hit delete, and let's do y is greater than. Now this then becomes the relation. Okay, so -2 times x plus 6. Enter. You can see it there. Now you might be wondering, well, is that a dashed line? Yes, it is. You can see it there. It's showing that it's not including that line. Okay, and then we hit tab, and we're still in relations, so I'll type y control equals to give me less than or equal to x plus 2. You can see they overlap here, and really this darker shaded area is now the region that satisfies both of these inequalities. So this is the region we'd be interested in. Also, this intersection point would be one of these critical points. I think there was a name for it, I can't quite remember at the moment, but these are sort of your critical points, at the intersection and your x-intercept as it would be there. So to find the intersection, you could very much set these up as your ordinary y equals -2x plus 6, y equals x plus 2. Find where they equal each other. So x plus 2 equals -2x plus 6. Let's take 6 from either side and take x from either side. So that will be positive 4 and 3x. If I sub that into, I'll sub that into 2. So then I get y is equal to 4 on 3 plus 2. So that's 1 and 1/3 plus 2, so 3 1/3, or obviously 7/3. Let's have a look to see if I'm right. I hope I'm right. So menu, analyze graph, intersection, go below, go above, x in decimals, but yes, you can see, I think there's a way I could set that to exact values, but we can see I'm got that right there. Okay, now look through the example in your book, and look back through the YouTube videos from last time. They might also be covering this type of thing.